So today's topic is Facebook Hive POC. In our last class, we explored that Facebook is extensively using Hive, and we did installation and some basic practicals. But in this POC, we will be exploring the advanced feature of Hive. So this is a POC that you can say proof of concept, or you can say a mini project. So we will start the class with the agenda. So the agenda for this class is Hive uses at Facebook, sample click underscore history data, create table in Hive, static partitioning, dynamic partitioning, mixed partitioning, UDF, that is user defined function, then temporary UDF, permanent UDF. We will take a use case example, and the last but not the least is we will be talking about Hive scripts. So this is the agenda for this POC, which we will be covering in 2 days. The first half we will be covering today, and the second half we will be covering in tomorrow's class, and everything will be practical. So let's start with the first one, that is Hive uses at Facebook. So you know that when we open a Facebook, on the right side of Facebook home page, you can see different type of advertisements that may be related to garments, that may be related to any technology, that may be related to any life insurance policy or any gaming website. Depending upon our likes and dislike, we may click on any advertisement, and that information is being captured by Facebook team to do some business analysis. Because depending upon the preference of people from different age group, from different geographical location, Facebook can decide like you may be interested in which type of advertisement, and accordingly Facebook will be displaying those type of advertisement for you. So that means Facebook can customize the different advertisement as per your geographical location, or as per your preferences, and as per your age group. So details are captured in the form of text file, because ultimately whether it is Hadoop or it is Hive, we will be dealing with text file only. So once the detail about your preference, once the detail about the different activity whatever you are performing on Facebook, once those activity have been captured in log files, those text file or log file can be processed using either Hadoop or Hive. Whether it is Hadoop or Hive, both uses MapReduce framework to process large amount of data. Because Hadoop is completely a MapReduce framework, and Hive, in which we write our SQL queries, which also converts into MapReduce job and executed on Hadoop cluster. So Facebook is extensively using Hadoop and Hive for business intelligence. The main purpose behind capturing all these details and doing the analysis is enhancement of business. So this is very brief about the uses of Hive at Facebook. Now let's check it out which type of details are being captured by Facebook team. So when you are logging into Facebook from any geographical location from the globe, and you are clicking on any advertisement category, Facebook team is immediately capturing your details, like your user ID, which uniquely identifies you. The day may be Monday, Tuesday, Wednesday. Why those guys are capturing the day? Because they may be interested to find out some analysis based upon weekdays or weekend. So that's why they are capturing the day. They are capturing the time so that they can do some analysis on time based. Location of user. that is the country from where the user has logged in, and the last is advertisement category. So these are few details which we are considering that Facebook is capturing. Actually, Facebook is capturing which details? Those details are completely internal to Facebook. Facebook does not share those information with anyone. But for our mini project, for our POC, we are considering that these 5 details are captured for every click on Facebook page. Okay, so let's have a quick look at the sample data. So username is Sandeep. The day on which he clicked on some advertisement is Friday. The time is 5:30 p.m. The country from where he has logged in is India, and the category on which he has clicked upon is games. So the guy with the name Sandeep, on Friday at this time from India, he clicked on gaming website, and these details have been captured in this text file. Similarly, from some other location, another lady Ekta on Friday at 4:23 a.m. from Brazil, she clicked on technology website. So this way different users along with their day, time, their login country and their uh, advertisement category on which they clicked on. This is just a sample data. Actually, the actual data which we have is 50,000 rows. So if you have a look at the sample data, that's fine, because as discussed in the last class, that in Hive we have a look at the data first and then we decide like how many columns should be there in our table and what should be their data type. So if you have a look at the sample data, that's fine. You don't need to look at each and every row of your data, because your complete data may contain millions, billions or trillions of rows. So by looking at these 5 values, first of all, one point will come into your mind is our table should have 5 columns. One is for user ID, second one is for day, third one is for time, fourth one is for country, and fifth one is for advertisement category. Okay. Now what about data types? First one is name, so data type will be string. Second one is again a day name, so that is also string. Third one is something numerical, but it contains semicolon and it contains AM, PM. So ultimately we will be taking string again. The next is country name and then advertisement category name. So basically all of my 5 columns are string only. So not an issue. We can create a table with some name with 5 columns with their data types as string, and then we can load the data from our text file into our Hive table. So this is all about our sample click history data of Facebook. So we are moving to the next slide, and the next slide is create table in Hive. As we have already had a look at our sample data, it's time to create the table. So this is the command for creating the table. You can quickly have a look. Create table, click underscore history. I have just given some name, click underscore history. User ID, that is string, day, that is also string, time, that is also string, country, that is string, and the last add category, that is also string. Okay, these are my 5 columns, and you know that in Hive specifying the column names and their data types is not sufficient. We need to provide one more line, that is row format delimited fields terminated by /t, again tab, because our this data is also tab separated and stored as text file. Okay, So let's create this table and let's load some data into that. So just give me a moment, let me start my terminal. Okay, first of all, we have to make sure that our Hadoop must be running. So let me check it out, JPS. Okay, secondary name node, job tracker, data node, task tracker, and name node. All the required processes are running. That's good. Before starting the Hive, one more thing which we need to take care is our name node should not be in safe mode. So let's check it out. So to find out that, first of all, I need to move to the bin directory of Hadoop. Okay, I will type /Hadoop dfs admin -safe mode space get. Safe mode is off. Okay, that's great. That's what we are looking for. So now we will move to the bin directory of Hive so that we can start our Hive. So now you can see that we are inside Hive terminal, and if we want we can press Ctrl L, which will clear our screen. So if I want, I can type show tables just for checking if we have any tables. Okay, it is saying that one table is there, that is employee, which we created in our last class. Okay, but today we are doing our Facebook Hive POC, so we will be creating one more table. So what I will do is, let me copy the command from PDF so that we can save some time. So I will be copying this complete command so that we can quickly create our table. This one. And I will paste the command into the terminal. Okay, okay means the command has been successfully executed. Can we check show tables again? Yes, great. Click _ history is coming now. And if I will do select star from click history, it is saying okay. But there is no data displayed because we have just created the table. We don't have any data till now. So we will add some data into this. So the data is located just give me a moment. I'm coming back to PDF now. Okay. Now the next command is load data into table, and command is load data local in path, then the complete path of my file, that is /home/nearest PDF, inside that Hive, inside that Hive _POC _sample _data.txt. And I'm sure that you must have received this file as well. This file contains 50,000 rows. Into table click _ history. So if you want, I can show you where this file is actually located. Just give me a moment. This is my home, this is my PDF, this is my Hive, and this is the file Hive POC sample _data.txt. Okay, I can open that if you want, but it contains 50,000 rows, so it will take some time to load. Yes, you can see now it's loading because there are 50,000 rows in this file. Anyways, this is just for your reference where your file is located and which type of data it contains. So now we will simply execute that command to load the data into our Hive table. So let me do one thing. Let me copy this command from PDF so that we can save some time. Copy. What I will do is I will edit this command. The reason being is whatever double quotes are displayed in this PDF, those are creating some issue sometime. You can see now. These double quotes, I will remove this and I will do it again. Like there's some difference between these double quotes and whatever is displayed over the PDF. So you may need to do this one also. Or you can type your command manually. So I will copy this. Yes. I will come on terminal now. And I will execute this. Okay. The load data command I have executed. That means now the 50,000 rows have been loaded into your click_history table. First of all, let's clear the screen by pressing Ctrl L. Yes. And now we will do again select star from click_history. Okay. If I will do this, this will start displaying 50,000 rows over the terminal. Do we really need that? No, we don't need that. So we have an option. We can specify the limit, how many rows you want to display. Let me give the limit like this, limit 5. That means I simply want to see 5 rows, semicolon, press enter. Yes, you can see now. Sandeep on Friday 5:30 p.m. from India clicked on cosmetic website. Shravan on Thursday 2:42 a.m. from UK clicked on gaming website. So only 5 rows are displayed over the terminal. One more thing which we may be interested to confirm is, do we have 50,000 rows in our table? Can we confirm that? Yes. We can do select count star from click_history, semicolon, enter. Okay. So this query has been converted into MapReduce job, and this, I mean, the output of this job will be the output of our query. So let's wait for some time, and the total records count in your table will be displayed over the terminal as the output. So mapper part is complete, that is 100%. Reducer part is running. It might take few seconds, and then the output would be displayed over the terminal. So you can see now map 100%, reduce 100%, and the final output is this 50,000. This one. That means our table contains 50,000 rows. So this is very brief, like your client has provided you the data, you have created a table accordingly, and you have loaded the complete data into your Hive table. So we can proceed now to the next slide, and the next slide is about partitioning. Okay, so you know that behind every Hive table there is a text file stored in HDFS. I had shown this thing to you in our last class, that when we load the data into our Hive table, in the background that file is copied into some directory in some location on our HDFS. That means every Hive table is backed up by a text file, and when we are firing any query on our Hive table, the query is converted into a MapReduce job, and that MapReduce job is directly dealing with that text file. So we need to scan the complete file to find out the result. Yeah, that's true. Suppose I'm talking about this Hive data only. Suppose I want to find out how many Facebook subscribers are there who are logging into Facebook from India. Okay. Basically, I am talking about only Indian subscriber, but still you need to scan complete 50,000 rows to find out the answer to this question. That's really true. So we can use partitioning to increase the performance of Hive queries. Partitioning means if somehow we can store the related data separately, the total time taken to complete our query can be decreased. Let me explore in more detail at some lower level. Like if your complete click history data is not stored in a single file but stored in multiple files. Suppose all the data related to Indian users is stored in a separate file. All the data for US users is stored in a separate file. For every country, the data is stored in a separate file. Total number of rows is still 50,000. The only difference is 50,000 rows are not stored in a single file. Instead, 50,000 rows are stored in different files, multiple files. So, what benefit we will get by doing this? Now let me come back to the requirement again. I want to count the number of users who have logged in into Facebook from India. This time, do I need to scan total 50,000 rows? No, I don't need that. I can simply scan that file which contains the data related to India. That may be 5,000, maybe 8,000, maybe 10,000, but definitely less than 50,000. So I can get the same result by scanning less number of rows, just because the data is stored in multiple files instead of a single file. That is known as partitioning. And there are two types of partitioning in Hive. One is static partitioning and another one is dynamic partitioning. So we will be talking about these two types of partitioning in more detail with their practicals. So let's start with the first one, that is static partitioning. Okay, so first of all, out of all the columns, you should decide like which column you want to use as a partitioned column. In this example, we have user ID, we have day, we have time, we have country, and we have add category. Let's do one thing. The data related to one add category, suppose games, should be stored in a separate file. The data related to cosmetic should be stored in a separate file. Similarly, data related to individual add categories should be stored in corresponding files. So that would make our I can say query time less. So let's check it out. The command. First of all, we need to create a partitioned table, and then we will load the data into our partitioned table. So let's check it out. Create table, click underscore history underscore part. I have just given a meaningful name, click history partition. User ID string, day string, time string, country string, bracket closed. Okay, I think we have specified only 4 columns. Where is the fifth one? Fifth column, that is add category, is my partitioned column which needs to be specified separately, partitioned by add category that is also string. So this is the way we can create a partition table. And the last thing, row format delimited fields terminated by tab stored as text file. This command will only create a partition table. We need to load the data explicitly into the partition table. So first of all, let's create the table and then we will load the data as well. So I am copying this command. First of all, I will clear the screen. Okay, and I will paste this command. Okay, means the command has been successfully executed. If you want, we can check it out. Show tables. Yes, you can see the second one, click underscore history underscore part. This table has successfully been created. but only the table has been created. There is no data inside that. So coming back to PDF, we will talk about the data loading now. When we loaded the data into a simple Hive table, we loaded with the help of a text file. But can we load some data into partition table from a text file? No, we can't do that. The reason being is text file contains random data. One row is related to games category. Second row is related to cosmetic category. Third row is related to life insurance category. How would I identify my related rows? Because when I am inserting the data into partition table into a partition, that means I will be selecting all specific rows and inserting into that. So let's check it out. Insert into table, click underscore history underscore part. First of all, we will be selecting the data from our simple table. You know that our simple table contains 50,000 rows, and all those are mixed random rows. Games related, technology related, life insurance related, all those things. What I will do is, I will be selecting all the rows which are related to games, and all those selected rows I will be loading into one of the partition into my partition table. So let's go through the command once again. Insert into table, click underscore history underscore part. And in which partition you are adding? Partition add underscore category is equal to games. That means we are loading the data into games partition. Now what data we are inserting? Select user ID, comma, day, comma, time, comma, country from click underscore history where add category is equal to games. So out of 50,000 rows, we are selecting all the rows for which add category is equal to games. And this selected data we will be inserting into this particular partition. So let's check it out. I will be executing this command. So let me copy this. Okay, I have copied this command, but before I paste this command into the terminal, I would open my browser first. And I will show you that if I will go to the location of this table, you will not find any data. You know that we have just created the table. We haven't inserted any data. Let me show you. Click on browse the file system. Yes. Click on user. Yes. Click on Hive. Yes. Click on warehouse. Yes. And here you will find directories for your tables. We have click history. We have click underscore history underscore part. Let me show you the content of click history. Hive underscore POC underscore sample underscore data.txt. If you remember, we loaded this file into our Hive table. So internally that file has been copied at this location. Shall we try for the another table? Yes, we can try that, but you will not find anything. Yes, you can see this empty directory because we have just created the table. We haven't inserted any data into that. Now we will add the data. We will execute that command which will be fetching the games related data from my simple table and inserting into one partition of my partition table. So let's do that. Then we will come back to this browser page and then I will show you. So going to terminal, we'll paste that particular command. Okay, total MapReduce job is equal to 3. You can see now there are behind this particular query there are 3 MapReduce job executed. So this MapReduce job will keep on running, and once this job will complete, we will go back to the browser and then we will see what happened behind this query. Okay, so in the meantime, this query is completed. We can come back to our PDF. Okay, so this was about static partitioning. One thing which you might notice is this command will fetch the data related to games and insert into games partition. Okay, that's fine. What about other categories? What about cosmetic? What about life insurance? What about garments? Yes, that means you need to execute different queries for different values. Okay, that means if I have 10 different add categories in my data, I need to execute 10 different commands. Yes, that's true. But that is something which is not good. I mean, if I have total 100 unique values, suppose country, I may have 100 different countries in my data. Do I need to execute 100 commands? Yes, you need to do that. So this is a limitation of static partitioning, which we will resolve in the next type of partitioning, that is dynamic partitioning. But before that, let's check it out if that query has been completed. Okay, that has been completed now. That's good. Coming back to browser, let me refresh this page. Previously it was empty. Yeah. Inside this directory, I mean click underscore history underscore part, one more directory has been created. Add category is equal to games. Is it a file? No, it's not a file. It is a directory, which is telling you that this directory contains the data related to add category is equal to games. I can click on that and you will find a file inside that, this 000, whatever it is. And if you will click on that, you will find all that data for which add category is equal to games. That means that particular query has fetched games related data and inserted into this particular partition. So this was about games, and that's why one directory has been created. Add category is equal to games. If you will execute a similar command for life insurance, one more directory will be created. Add category is equal to life insurance, and if you will click on that, you will find a file inside that would contain the data related to life insurance. So now 50,000 rows which were part of a single file, now the only difference is 50,000 rows are splitted among multiple files. That's the only difference we are getting. Can we check it through the terminal? Yes. Let me do one thing. First of all, I will clear the screen. I will do select count star from click underscore history underscore part. You know that first of all I have inserted the data related to games only. The remaining add categories are still pending, but still I want to check it out, like how many rows have been inserted into my table. So I can do that. Select count star from click underscore history underscore part. I will press enter. This query has been converted into a MapReduce job, and within few seconds it will give me the result how many rows have been inserted into my partition table. Similarly, once you will insert for cosmetic, you will insert for life insurance. Once you will add the data for every partition, total number of rows in this table will also be the same, that is 50,000 rows. So you can see now map 100% reduce 67%, it's running. Okay, 8321, you can see now out of 50,000 rows, 8,321 rows are related to games. Similarly, few thousand may be related to life insurance, few thousand maybe are related to cosmetic, garments, like this one. So total number of rows will be again 50,000, but this time these are stored in different directories, these are stored in different files, so that for a small query I don't need to scan 50,000 rows. Let me check it out. Suppose I'm interested to find out like how many people are clicking on games. I can do this by scanning this simple table. Let me show you. Scan this data, this one, which is 1.78 MB of data, but the same output. I can find out just by scanning very less amount of data. That is, let me show you. I will go to this, I will go to games, and the size of this file is 226 KB. That is only I think 8 times or 10 times. So the same output we can get just by scanning the less amount of data. So why do we need to scan the large amount of data? So this is the benefit which we are getting with the help of partitioning. So I'm coming back to terminal. So that was all about static partitioning. What is static partitioning? How we can use that to load the data, and what are its limitations. That is, we need to execute different commands for different categories. So we are moving now to the next one, that is dynamic partitioning. Okay, so dynamic partitioning is disabled in Hive. Why it's like that? Because in static partitioning we were forced to execute different commands for different ad categories. That means if there are 10 different values, I need to execute 10 different commands. But in dynamic partitioning, even a single command will do all the magic. You simply execute one command, it will fetch the complete data from your table. Every row will be going to its corresponding partition. So that is more easier as compared to static partitioning. But again, if your partitioned column contains different unique values, maybe thousands of unique values, that means the single query will create thousands of different directories, thousands of different files. That is a time-consuming process. That's why, to avoid this type of scenario, dynamic partitioning is disabled in Hive. But as per your need, whenever you need dynamic partitioning, you can enable that. That's not a big deal. We need to execute these two commands. Set hive.exec.dynamic.partition is equal to true. And the next is hive.exec.dynamic.partition.mode is non-strict. These are the two commands which you can execute in our Hive terminal, and your dynamic partitioning will be enabled. After that, you can simply execute this command which will be loading the data into different partitions. So let's do one thing. First of all, let's create a partition table. One more partition table we will create, and then we will be loading the data into that table using dynamic partitioning. So I will copy this. I will copy this and I will edit this because I need to edit the table name. Okay, I will make it click_history_dynamic. I am just giving some name. Okay, now I will execute this command, and then we will be loading the data using dynamic partitioning. First of all, I will clear the screen. Okay, if you can see, if you want to see, we can do show tables. Yes, you can see the second one, click_history_dynamic. That table has been created, but it does not contain any data as of now. So instead of using static partitioning, which is very long process, we need to execute for different category, I will use dynamic partitioning, and I will populate all the partitioning with the help of a single command. So let's do one thing. First of all, let's open the browser. We'll go back, we'll refresh the page now. From where I can refresh? Yes, you can see the second one, click_history_dynamic. I will click on that and you will find empty directory. Yes, absolutely right. There is nothing inside this directory currently. So coming back to PDF, this is the command which is used for populating the data into a partition table using dynamic partitioning. And the command is insert into table click_history_part partition add_category is equal to, there is no is equal to, because I am not specifying any value. I am not telling that add category is equal to games or add category is equal to cosmetic or add category is equal to garments. I'm not doing that. That will be done internally by this query, and this single query will populate all of your partitions. And then select star from click history. I am not using any where clause because this time I am not selecting games related data. I am selecting the complete data from my table that would be automatically distributed among different partitions using this command. So let's copy this. We'll execute this command. I will copy this and I will edit that as well because I need to change the table name. Otherwise, it will insert into that part 1 table. So not an issue. We will change that. Instead of part, I will make it dynamic because whatever table we have just created, we will inserting into that. Yes, insert into table, click underscore history underscore dynamic, partition add category, select star from click history. My simple table. Okay, I will copy this. Control C. Coming back to terminal. Yes. We'll paste this command and we'll press enter. Okay, it is giving the error. The reason being is I didn't enable dynamic partitioning. Okay, not an issue. We will do that. We will copy this. Come back to the terminal. Paste these 2 commands. Yes, now the dynamic partitioning has been enabled. First of all, let me clear the screen. I will again copy my command. Copy. Coming back to terminal. We'll paste this. We'll press enter. Yes, total map-based job is equal to 3. So this job will be fetching the complete data from my simple table, that is click underscore history. It will be scanning each and every row, and accordingly it will be sending that particular row to the corresponding partition. So after this command, you will see that behind that directory 6 different directory will be created for every partition. So I think that has been almost complete. Yes, yeah, you can have a look at this. Yes, loading partition add category is equal to technology, add category is equal to travel, life insurance, garments, cosmetic, games. So for all 6 add category, data has been loaded. That's great. Let's come to the browser and we can check that. Okay, I will refresh this page. Okay, you can see now add category is equal to cosmetic, add category is equal to games, garments, life insurance, technology, travel. A single command has done all the magic for us. Again, if you want to see the cosmetic related data, you need to you need to click on this one, cosmetic. Once you will click on cosmetic, you can see the output file, and if you will click on output file, you can see the data are related to cosmetic. One thing which you might notice is it is saying that Sandeep, Friday 5:30 p.m. India. Where is cosmetic? Where is add category? Similarly, for the second row, Mahesh, Wednesday 1:52 a.m. Brazil. Where is add category? As all this data is available inside add underscore category is equal to cosmetic, that means add category for all these rows is cosmetic. That is not displayed. That's a different thing. That's not an issue. But if you will fire any query on terminal, this add category will also be displayed. Don't worry about that. Let me show you. What I will do is, first of all, I will clear the screen. I will do select star from click underscore history underscore dynamic, and I will give the limit, otherwise it will start displaying 50,000 rows. Limit suppose 10 semicolon enter. Okay, you can see now Sandeep, Friday 5:30 p.m. India, cosmetic, all this thing. So this way everything will be displayed over the terminal. The only thing is it is not displayed in the file itself because that file is specifically for cosmetics, so that's not required. So this way you can use static partitioning and dynamic partitioning to increase the performance of your Hive queries. So I'm coming back to PDF now. So there are two types of partitioning in Hive. One is static, another one is dynamic, but I have introduced one more type of partitioning, that is mixed partition. This is the name which I have given. You might not find such name, mixed partition, in any PDF book. That may be possible. What I am doing is, instead of one column, I am partitioning my column based upon two columns. That's possible. And while inserting the data, one column I am using as static, another one I am using as dynamic. That's why I have given a new name, mixed partition. Let's have a look. Create table, click underscore history underscore part 2. User ID string, day string, time string, partitioned by country string, comma, add category string. This means this table is partitioned by two columns, country and add category, and the remaining things are same. Row format delimited fields terminated by /t, that is tab, stored as text file. Okay, this is about creation of a partition table with two partition columns. What about inserting the data? You can use static partitioning. That means while inserting, you need to specify the value of both the columns. You can use dynamic partitioning. That means you need not to specify any value for any of the column. But just for some experiment purpose, I have done mixed partition. Let's check it out. Insert into table, click underscore history underscore part 2. Partition country is equal to India. I am specifying the value. That means it is a static partition. Comma, add category is equal to, there is no is equal to, because I am not specifying any value. That means this is dynamic partitioning. So one column is used as static, another one is used as dynamic. Okay, not an issue. Select user ID, comma, day, comma, time, comma, add category from click history where country is equal to India. Because I myself specifying that I want to insert into India category, that means I need to select the data related to India only. That's why I have put a where clause for country is equal to India. So this will be selecting the data for which country is equal to India and for all the add category, because add category is not specified. That is all the add category, because that is dynamic partition. So this will be creating a partition table with two partition column, and this command will be inserting the data into specified partitions. So this mixed partitioning I am leaving for you so that you can do the practice for this, and with this slide we are done for the day.